ठीक है. What chapters do we have to do today? The first chapter is
Enthalpy, bond and say some matter.
So let's start with bonding.
Sorry.
है ना? What is bonding?
Joining of two molecules, atoms, something.
What is bonding?
What is?
Of elements.
I was close.
Very close. I agree. You are very close. So can you?
That was so random.
That is so stupid.
नहीं मजा आया, नहीं मजा आया. यहाँ पे आ जाओ. यहाँ पे सुनो यार. Okay.
Sorry.
फटाफट. What is bonding?
Bonding is the attraction of two electrons. No, that's
Chemical bonding we are talking about. Okay, it has something to do with electrons. So atoms combine
To form new substances.
Why?
Because they want to
because
achieve
they're not
valency.
stable. They need to
Attain a
stability.
Stable.
nearest
Closest to 8 number.
noble gas configuration.
Noble gases.
Closest noble gas configuration करने के लिए, है ना?
Yes.
So what are the types of bonding that we know? मेरे को मालूम है.
Three: ionic, covalent,
Covalent and metal.
metallic.
बस.
Metallic.
Ionic is
Then
also
there is those
electron.
pi bond, sigma bond.
Oh,
There is also coordinate bonding.
And yeah, they
yes. Oh, yeah.
है ना? अभी सबका quick recap करें. So
Yes.
ionic bonds are so called because they have
Plus
ions. है ना? Plus is cation, negative is anion. Covalent bonds share electrons. Metallic bonds are about cations
and delocalized.
in delocalized electrons, and coordinate is about
When one atom provides the electrons
Share complete.
for complete sharing.
In unbalanced sharing of electrons.
Yeah, only one atom.
only one
Sir,
shares
coordinate is
electrons.
more like sharing. Covalent is more like trading electrons.
I don't think so.
No.
Sharing
Ionic-
मतलब
I
क्या
don't
होगा?
understand it.
तो discuss करें. मैं क्या बोलूं?
Coordinate is a donation. You giving.
I mean, you.
बट तेरे पास भी है ना, डोनेशन को क्या बोलते हैं?
जो
मेरे
मेरे
पास
पास
बॉन्ड
ना हो।
मेरे पास बॉन्ड करने के लिए है नहीं, तो आप मुझे दे रहे हो कि ये ले और फिर मेरे साथ बॉन्ड करो.
But
But
then
it can't
I
be
am not
donation.
letting it go. Donation मतलब
मैं भी साथ में ही जा रहा हूँ.
ऐसा तो नहीं हो सकता ना.
It's like Loki marriage.
Huh?
It's like Loki.
This is a dated terminology. I do not understand this.
Native bonding is that when out of the two atoms, only
One is providing the electrons for sharing.
Such a good example though. Like maybe the H two अभी मैं हो जाता.
Yes, bro.
Okay.
When you explain the Marwari terminology, तब समझ में आता है.
इन तीनों में है ना, giant bonding भी होता है ना?
Yes.
What is a sign that there is a giant structure?
High melting point.
High melting point and boiling point. ठीक है, तो थोड़ा सा recap 9th का है वैसे, but if it is ionic, it will conduct electricity when molten or when it is aqueous. But when it is solid, it will not conduct electricity. है ना? But if it has high melting and boiling point and conducts electricity when solid, it has to be a
Metal.
Metal.
Or
because it
covalent.
has delocalized
Or
electrons.
covalent.
It cannot be covalent.
Graphite.
There is only one situation where it can be graphite.
Silicon.
No,
Does
silicon
not.
does not.
Silicon does not. It is a semiconductor. Semiconductor.
Does. It's a
But then
semiconductor.
semiconductor में तेरे को कुछ और condition देनी पड़ेगी, तो वो conduct
हाँ.
होता है.
Thermal conductor.
तो in the simplest term अगर कोई ऐसा
No.
सिर्फ बोले तेरे को कि high melting point, high boiling point conducts electricity when solid, तो सीधा conclusion
Metal. हाँ.
है ना, does not conduct electricity, has high melting point, has high boiling point.
Giant covalent.
Giant covalent. This makes sense.
Yes, sir. Yes.
If it has high melting point, high boiling point, does not conduct electricity in any form, it has to be a
Giant.
right? So these are the bonds that we are looking at. And all of these bonds have one reason or another why two particles are coming together. But why does it happen? Simply because they want to complete their orbit, right? They do it in different manners. Sometimes they transfer electrons, sometimes they share electrons, because metals have formed cations and have free electrons. Right? They have free electrons. Free electrons, so they have a high attraction with cations, and that is why this structure has high melting and boiling point. This is about it. What we have to study this year. This year we are more interested in intermolecular forces. What are intermolecular forces?
The forces between molecules in an element.
Okay, so the bonds are between a compound. Okay, let's say oxygen. So hydrogen and hydrogen, these bonds are what we have understood till now. But why will one water molecule attract another water molecule is what we are interested in studying. Okay, so let's start with first thing, that all of these intermolecular forces are simply known as van der Waals forces. है ना? VDW, van der Waals forces. Now all of these are very weak forces compared to bonds. है ना? The strength of these forces compared to a carbon dioxide bond, the double bond, is very weak, but it is strong enough that technically water is a covalent bond, right? Now molecular covalent compounds like water should have been gases, but they are not.
The liquid.
They are liquids. Iodine should have been a gas, but it is a solid, right? Even though it's not a compound, there is a bond, and these van der Waals forces lead it to having a higher melting and boiling point, having it a denser state. ठीक है? तो first thing we need to understand is that there are polar and non-polar molecules. But even before we understand polar and non-polar, we should know something known as electronegativity. What is electronegativity? About?
So if an H2 molecule bonds with another H2 molecule, it's intermolecular.
थोड़ा difficult ऐसे करो.
But in iodine, an atom and triatom bond together. So is
No,
that
I am talking about I2 and I2 attracting each other so strongly that iodine becomes a solid. I am not talking about I2 being solid. Okay? What is electronegativity?
The tendency of an
Tendency of
atom
an atom to attract.
What will happen if there is electronegativity? One of them will be permanently negative and one of them will be permanently slightly positive. Right? Because of which there will be a constant dipole. Right? These compounds are known as polar. What will non-polar look like? Either there is no electronegative pull, or if there is an electronegative pull, it is equal on all sides such that no poles appear. Right? This is non-polar. What happens? See, it's very obvious that if it is polar, what will happen? These negative sides will attract positive sides of other atoms, other molecules rather, and have intermolecular forces which will make them behave the way they do. Yes.
Is there a way to identify whether the compound is polar based off of the molecular formula alone?
Molecular formula, if it is an organic compound, no. If it is not an organic compound, you can almost say that.
So,
So let's say there is.
Like if I just gave you, for example, let's say SO, something like this, SO3, how would I know?
SO4 itself has a charge. There is
हाँ.
no question of it being polar or non-polar.
Correct.
It has a complete charge.
हाँ.
है ना? Polar, we are talking about polar when the total charge is 0. Here, the total charge of this compound is 0. But when you look at its appearance, its structure, it appears that it is attracting other molecules, which makes us understand that there are some interactions. When we tried to find evidence of why these interactions were happening, we found out that they were polar. So, because now we know that there are chlorine, oxygen, fluorine and nitrogen, these are very electronegative. So, if something is connected to either of these, you can expect the molecule to be polar. Otherwise, no. Otherwise, the difference in electronegativity is not so much that it can create a successful pull. For example, SCl2 will not be polar.
So if I had, for example, H2SO4, H2SO4 would be polar because
it is H2SO4 is not a covalent compound.
Oh,
SO4 2 minus is a covalent compound. It's a radical. There is some sharing of electrons, but it itself has a charge of 2 minus. So there is no question of it being polar. It is negatively charged.
Shouldn't SCl2 be polar because it's connected to Cl?
But it is getting pulled on both sides.
Scales,
So they will cancel out their polar movements.
So even if it's something like CO2, it's
Huh.
non-polar because
Yes.
it's CO2.
Yes. Right? So generally looking at a molecule, you will be able to identify if it's polar or non-polar. Right? So if it is polar, it is obvious that there will be some interactions. Right? One of them is hydrogen bonding. Right? You can just say that polar is permanent dipole, right? If it is polar, there is permanent dipole. Example, water. Example, HC. Right? Example, hydrogen fluoride. Right? So, if hydrogen is bonded to oxygen or nitrogen or fluorine, in these three cases, the polar moment, right, the difference in that charge is so much that the attraction is strongest. Of all the bonds of the subtypes that we are going to look about van der Waals forces, these are the strongest, right? Hydrogen bonding. In water, hydrogen bonding is the one that is responsible for water's liquid state, right? So what has happened is, let's say, right, these molecules, they are getting attracted to like this, right? There is a bond between this hydrogen and this oxygen. This hydrogen is then attracted to other oxygen.
There was this question in MCQ. It said how many hydrogen bonds does one molecule of water make? And the answer was 4.
Makes
But
sense.
how?
दो हाइड्रोजन
Because-
So HOH, right? This will be, let's make it a dot. This will be bonded to another hydrogen, OH. है ना? Then this will be bonded to another oxygen. This will be bonded to another oxygen. Can be bonded to another hydrogen
How?
oxygen.
Because it has 2.
No. Whatever, let's say there is plus delta and plus delta. Technically, there is minus 2 delta charge over here.
Yeah.
Only that this balance is out, so it can attract more. ठीक है? वापस आ जाते हैं. So this is what hydrogen bonding is. Polar में, polar, non-polar, polar में सबसे strongest hydrogen, right? Even if it's not hydrogen, you can call it permanent dipole. Permanent dipole में क्या होगा? Permanent dipole में you can say that because there are permanent dipoles, they will attract each other, right? It will increase the density, the melting point, the boiling point, and everything.
So compared to a normal TD-PD bond, hydrogen bonding is stronger, no?
I think there is a comparison given in your textbook. it's not. There was a comparison given, I don't know if it was an older edition, clearly like if all the others were responsible for let's say 8 or 10 units of forces, hydrogen bond was responsible about 40 units of force. So it is that strong. Okay? Now if it is polar, right? But if this is not the configuration, for example HCl, right, bonded to chlorine, then this is just permanent dipole attracting other permanent dipole. Okay? What if it is non-polar? Let's look at example of bromine, right? Because particles are randomly moving, one bromine can approach other bromine molecule like this. What will this make? This will make this bromine, because there is also a cloud of electrons around this bromine in this region.
Might be more negative.
Yes, and therefore the electrons that are lying exactly in between will get pushed here. This will become minus negative and this will become plus negatively charged. This is instantaneous. Now imagine if this is negatively charged, another bromine that is just beside will automatically become positively charged, even if it was not approaching. There is a chain of this happening. As soon as this disappears, right? What will happen over here?
Lose charge.
This will lose charge, but by the time there is one more molecule which is already attained charge. By the time this loses charge, one more chain
So
has
does it return back to the
appeared.
same molecule?
It may. Basic understanding is these are not permanent. They can change their position. But nevertheless, always there will be clusters of charges like this. Right? Now here, the more the number of electrons, the greater the chances of instantaneous dipoles occurs. Right? Which tells us why iodine is solid. When iodine molecules come near to each other, the instantaneous dipole becomes so strong that they stick to each other. Okay? Which is why as you go down the group, you look at any group in the periodic table, you will find as you go down the group, the character becomes more and more metallic. It goes solid, right? Its electronegativity decreases. Why? Because of all of these things, right? Its radius is increasing, right? Nuclear charge increases, but radius is more influential. Its electrons have increased, so these instantaneous dipole will make it a solid, right? Makes sense till here. Now there is a very important what do you call theory that we have, VSEPR.
One question.
Huh.
This is true for the hydrogen. As you go down the group, the density increases and therefore the change state. What about the noble gases?
उसमें instantaneous dipole ही नहीं है ना, जैसे neon है, right? If one neon approaches other neon, where will the electrons go?
Oh, हाँ, it has to be bonded thing, right? Sorry.
No? Yes.
हाँ.
Sorry, क्या बोला? Question समझ में आया?
हाँ.
Okay. Now we have VSEPR theory. I am completely skipping dot and cross diagrams. If you don't know dot and cross diagrams, all the best for your course. We have VSEPR, valence shell, electron pair, repulsion theory. What does this tell us? It tells us that what will be the shape of this SCl2. है ना? क्या shape होगा इसका?
Non-linear.
Not with bend.
Q.
Because there are
Because there is no pair.
है ना? ये थियरी का सबसे इम्पोर्टेंट बेसिक क्या है? That you count the number of bonded pair, you count the number of lone pair, right? For the central molecule, क्लोरीन का फाइंड करने जाओगे तो उसके पास एक ही बॉन्डेड पेयर है, बाकी सब लोन पेयर है. So central molecule will dictate the shape, right? So you look at central molecule, you find out how many bonded pair does it have, how many lone pair does it have. If it has zero bonded pair, उसके पास कोई bond, sorry, if it has zero lone pair, उसके पास कोई lone pair ही नहीं, है ना? तो if let's say it has formed double bond, तो linear होगा. If it has 3 atoms around it, तो कैसा shape होगा? Trigonal shape होगा.
Trigonal.
Planar shape है ना, because it has no क्या नहीं है उसके पास? No lone pairs है ना. अगर lone pair हुआ तो pyramidal हो जाएगा. Trigonal था,
Trigonal pyramid.
अब कैसा हो गया?
Pyramid.
जैसे ही लोन पेयर आया पिरामिड हो गया. ऐसा क्यों होगा? Because all of these pairs, वो pairs है क्या? Pairs of so electrons.
SF is diagonal
Yes.
and NH3 is pyramid.
Yes. I was saying these are pairs of electrons. Because electrons repel each other, right? These shapes change. Most repulsion is between a lone pair and lone pair. Lesser between a lone pair and bond pair. The least between a bond pair and bond pair. Right? Now, the good thing about this is that if you remember the examples given in your textbook, you don't have to remember anything else. You don't have to always count the number of bond pair and lone pair. So we will look at all the examples from your textbook, right? So they have first given BF3, right? This central molecule has no lone pair. What should be the shape?
Triangle.
Right? If you look in your textbook, right, on page number 86, you will find that this is a 3D shape. So what they have done is they have drawn a dotted line over here and they have drawn this triangular shape over here. What does this mean? This means कि वही है, बस shape ऐसा. We were thinking it should be like this. They are saying that it's like this on this plane. Does not change anything, right? Yes.
So does trigonal planar mean that it's all at the same plane?
Yes. So for us, this was the plane. For textbook, this is the plane. That's the only difference.
Okay.
But
So
it's
the exam if you draw not
what does this show? This show that ये तीनों एक
plane पर है. That is true, but technically we still draw the way drawn before, right?
But textbook में ऐसा दिया है. उधर पे जाके सोचेगा ऐसा क्यों दिया? Anyway,
वो नहीं.
Even कौन सा पेपर लिखना है?
आज क्यों लिखना है?
सैटरडे में लिखा था कि इसका पेपर क्यों? एमबीए की वजह से.
देखो राशि ने टेबल पे पेपर रखा है. क्या लिखा है?
Organic में how do you identify planar and non-planar?
In organic, because carbon has all of its carbon has 4 bonds. So until unless it is forming a double bond, it has to be a tetrahedral structure.
So it's
Non-planar. Tetrahedral is non-planar.
Anything with double bond is planar.
Yes. Right? Because of sp2 hybridization. What we are going to see today. Anyway, then another example is C double bond. यहाँ पे कार्बन के पास कोई तो क्या हो जाएगा ये?
Linear.
है ना? फिर अपने पास है PF5. यहाँ पे PF1, 2, 3, 4 and 5 है ना? Trigonal bipyramidal because phosphorus does not have any
Lone pairs.
after it does not have any lone pair. The repulsions are equal. All the pairs are bonded pairs. The repulsions are equal. Because the repulsions are equal, one so P F over here, another over here, one over here. Let's say one more over here, and a each. Right. So what will it look like? It will look like a
pyramid.
ऐसे
Bipyramid.
दो पिरामिड ऊपर नीचे से
ऐसे ऊपर नीचे होंगे. All the faces are triangular faces. है ना? What are we joining? We are joining the nucleuses of all the atoms. ठीक है? ऐसे imaginary shape है, नहीं ऐसा तो नहीं दिखता है. Imaginary shape. Then there is sulfur hexafluoride. Again, if you look at sulfur hexafluoride, this also does not have any lone pair. Because this does not have any lone pair, तो क्या हो जाएगा? Octahedral. ये triangular था बीच में, उसके लिए क्या हो जाएगा? 4 fluorine in between, एक ऊपर एक नीचे. So here the angle is 120 and this angle is 90. For that every angle is 90. है ना? फिर हमारे पास एक और शेप होना चाहिए water. What is this shape? एंगल याद भी रखना है कितना है?
109.
क्या बात कर रहे हो?
107.
No, 107 was NH3.
104.
Oh.
Why should it be 104 not 109? If it is
I said 104.
Ah, that's
Double.
104.5.
it is
सर तो
because we
रट्टा
know
टेबल
the least repulsion is between bonded pair.
इसको कोई रट्टा टेबल है सर मेरा I don't remember any of the bond angles for any
तीन ही याद रखना
हमने जैसे
104 for bend,
okay
109
for
for this. बाकी सब कैलकुलेटेबल है ना, याद तो तीन ही रखना। बाकी सब तो तू शेप से कैलकुलेट कर सकता है। अगर ट्रायंगल है तो 360 डिवाइड बाय 3
Water is 104, 104.5.
104.5. ओके, एंड वन मोर, एक और था यार, NH3,
107
right? There is only one more pair. This is 107. Angle is always between two bonds and the smallest angle. इधर से ऐसा बना के बोलोगे कि कुछ और नहीं चलेगा। हाँ, वो भी 107 होगा भाई साहब।
आधा पेपर क्यों आधा क्वेश्चन मैंने इसमें काफी रखा हुआ करूँगा
ठीक है, understandable, makes sense, है ना? We will look at sigma and pi bonds, है ना? S का शेप spherical होता है, E का शेप डम्बल शेप, ऐसा कुछ होता है, Px, Py and Pz, right? Now these two can hybridize together and make a larger spherical orbital, है ना? Sub shell, spherical. Hybrids are always spherical in shape. Only then hybrids will be able to make all sigma bonds. If they are not spherical, how will they make all sigma bonds?
Isn't sp3 just like a dumbbell but with a larger on one side?
Obviously,
It's only
Sana, this
spherical.
is obviously like this. When it makes a sphere, it's obviously like this. What I'm trying to say is, it can accommodate an electron over here also.
Okay.
What are these spaces? These spaces are probability of finding electrons.
Yeah.
So that probability increases. That is hybridization. Okay. So for our understanding, hybrids are, which is why hybrids can form sigma bonds. What are sigma bonds? So let's say one bond and another. So S and S bond to form sigma. So let's say something ऐसा कुछ space होगा weird सा, but you can draw larger, है ना? So this is S and S, right? Then if this is a p orbital and this is s orbital, this is also sigma bond, right? Yes, perfect.
and then side by side.
This is also sigma bond, but this why is it the pi bond? Because it is
apparently
It looks like pi.
The symbol of pi.
Yeah, got it.
What is that?
Not even close.
okay,
That
not
would
even
be
close,
Q.
but sideways overlap produces
You
a
can
pi
call it
bond.
Pi,
jet.
sideways.
It also looks
I
like
don't
jet.
How
know.
sigma
I
is
don't
like sigma?
Right? Difference between a sigma and pi bond. In a sigma bond, the highest concentration of electrons is between the nucleuses, so it is comparatively more stable. Here, in pi bond, if these are the nucleus, this is where the probability of finding the electrons is most. So it is a little less stable. The bond length of a sigma bond
is longer.
is longer. Pi bonds, in that, p orbitals have to come near.
Is that also reasonably unstable because the two nuclei are closer together, so therefore the negative repulsion?
So are longer bonds harder to make or easier?
So if you find bond, yeah,
No.
Good
normal bonds, na.
No, longer bonds, are they easier to make or harder to make? Then
So
Harder.
No. Shorter bonds
then
are
should
harder.
be easier to react with.
see what happens is, if two particles which are positively charged together, right?
Now sample. अरे साचो क्या नहीं sample
तुम समझ गए मुझसे बोले? Okay, if they are positively charged, right, and they are surrounded by negative particles, there is a distance where the repulsion is minimum and the attraction is maximum. है ना? If they are closer than that, repulsion is more than attraction. If they are further away, attraction is repulsion. है ना? In either of the cases, the potential energy changes. Can we simply say that in either of the cases, potential energy changes? So there is a fixed distance at which the energy is minimum. At this distance, it is most difficult to break these bonds.
When they're far away.
Not that far away.
But okay.
So
See,
is it so pi bond so the
But then a pi bond.
Sentence finished, right? It's just a game of a lot of charges, right? So it's not that simple, but they cannot be too far away, they cannot be too near, right?
Isn't the same principle as strong nuclear force in physics? Ki after a certain distance it's very strong, but after a certain
No matter how much, now from here to touching of the nucleus, they will always repel each other.
Correct, but बहुत
बहुत
पास
fast है, तो strong nuclear का exist करेंगे से.
So is a pi bond easier to
Physics
break
का
or a
है.
sigma bond?
strong nuclear
Pi
force.
bond is easier to break, not only because of its distance, but also because of the electron distribution.
But is it does it
Here
have
the
a shorter
electrons are
distance?
between. Here the electrons are between the positive charges. Nucleuses. So the attack becomes more difficult. Electrons are going to
So
repel
pi bonds
negative.
are more reactive.
Yes, definitely. If you think about it, you can take ethene and just add bromine without any conditions and it will react. You take ethane, it will not react with bromine until unless there is UV light. UV light breaks down the.
It's like here pi bond is easier to break, but generally longer bonds are easier to break.
Yeah.
Yes, you can say.
Oh,
Thanks.
बस एज वाले लाइन पहले.
Thank you. बराबर है? Okay. हाँ ये रहा भाई एक सेकंड दिया है. Come to page 91. जिसके पास टेक्स्ट बुक है या फिर नोट पे सच में देख. Page 91, table 4.2. You look at that table. They have shown कि ionic bonding का 760 bond strength है. OH water covalent का 464 है. Hydrogen bonding 20 to 50. Permanent dipole is only 5 to 20. And IDID instantaneous is the least attractive. है ना? Page 90. अगर इलेक्ट्रोनेगेटिव में डिफरेंस में बहुत ज्यादा है तो ट्रांसफर ऑफ इलेक्ट्रॉन हो जाएगा. बहुत कम है तो बॉन्डिंग नहीं हो पाएगा, है ना? राइट? मेक सेंस? ठीक है.
बॉन्डिंग नहीं हो पाएगा.
एकदम कम हो तो.
ऑक्सीजन और ऑक्सीजन कोवैलेंट हो जाएगा, मतलब आयोनिक नहीं हो पाएगा. इस व्हाट आई एम ट्राइंग टू से, राइट? फिर और क्या है दिस चैप्टर? ओके, बिकॉज़ दिस हाइड्रोजन बॉन्ड्स आर वेरी strong. Water is a liquid. Hydrogen sulfide is a gas. है ना? Just below it hydrogen sulfide is a gas, but this is liquid. Then solubility. So if it is a polar solvent like water, it can dissolve ionic compounds. If it is a non-polar solvent like benzene, it can dissolve
non-polar.
ठीक है? तो soluble in water क्या क्या होगा? Ionic होगा.
polar.
Polar covalent compounds होंगे.
नहीं.
Dative भी होंगे ना?
Depending on-
Positive charges तो है उसके पास. कुछ
हाँ.
तो charge है dative के
Yes.
पास. So it should be soluble in water.
हाँ.
So ions will be
A lot of ions are, sulfates are soluble, hydroxides are soluble, a lot of 2 carbonates are soluble, all nitrate.
Benzene
Anything
is
with
an
a charge.
organic solvent. No?
Benzene is non-polar organic solvent, है ना? Organic and also non-polar. So solubility, conductivity, melting point, boiling point, और क्या affect होता है type of bonding से?
So hydrogen bonding in water.
No, I am saying what physical properties are affected. Melting point, boiling point, density, conductivity, solubility.
हाँ.
What else?
Surface tension.
Surface tension, yes. Polar.
I also don't understand how that's the whole surface area volume thing. The ratio. I'm very confused.
Take a cube, right? Let's say everyone can do this. जिसको डाउट है या जिसको डाउट नहीं है वो मेरे को समझा देना. जिसको डाउट है वो सुन लो. You can take a cube. Let's say it has 8 centimeter of each side. Huge. Okay, 8 centimeter of each side. What is its volume?
64 centimeter cube.
8 cube.
8 is 64, 64, 8 are 512.
512, correct. Right? 512. What is the surface area?
6 into 8 square is 64 into 8.
No need to multiply right now. But do you agree that this is in surface
Yes.
area?
Yes.
If I cut this cube into 8 pieces, let's say 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and यहाँ से भी 1, 2, 3, 4, 5, 6, 7, 8. कितने cubes बनेंगे?
64.
पक्का?
512.
512 cubes बनेंगे ना? Each with the side 1 centimeter.
8
But then
and
count
8.
it.
8 and 8.
ऐसे ही side में
जो आम का उपयोग
See, this is the rule, right? અહીંયાથી આમ કટ કર્યું 8, આમ કટ કર્યું 8 અને આમ બી કટ કર્યું.
Oh,
Right? 8. So we made cubes which have 512 cubes. What is the volume of these 512 cubes?
512.
What is the surface area of those 512?
1, 2, 3, 4.
There are 512 cubes.
Yeah.
Right there the surface area is more.
512 into 6.
512 into 6 into 1 into 1,
हाँ.
Yeah, so that's 512 into 6.
which
Yeah.
is a very large number, greater than this. So the volume
3012.
still is the same. The total volume is still same, but the surface area is drastically increased.
3072.
So the smaller the size, the greater the surface area. 3000. Either से 3000 मतलब obviously this is lesser than 500, right? Increased 6 folds at least. है ना? ठीक है. That also brings us to state of matter. States of matter. Right?
404. States of matter, I don't think there's anything new, na?
नहीं वो full relation होना
फिर वो formula है
नहीं Fullering,
New
whatever it is. आज नहीं explain कर रहा.
कभी question है
तुम लोग पढ़ लो.
the
Fullering.
store full
पूछा नाम पूछा.
the football
What does it resemble? फुटबॉल वाला ही
football.
पूछा है.
अच्छा.
बट ठीक है वो
Nano-
पढ़ लेना.
nano-
डाउट्स कहाँ पे आते
अरे
हैं?
वो भी है.
Behavior of
Ideal gas
gases.
laws.
हाँ तो वही तो
हाँ, PV को बनाना
डाउट यहाँ पे आते हैं gases.
हाँ.
Okay. जागो थोड़ा. चलिए एक्चुअली जेन्युइनली तो सूरज है ना
सर
सूरज.
You उठ ही गई.
Thanks. Okay. So gases, there are state points of gases P, B and T. Right? If it is a closed system, then N becomes a constant, and for plotting behavior of gases, R is also a constant. है ना? What is
pressure volume
pressure measured in Pascal? Volume measured in meter cube and not dm cube. This is measured in
So when is it measured in dm?
moles
moles
mole concept is about
divided by
So meter cube to dm cube is
1000.
minus 6.
1000.
Okay, minus 6.
minus.
And centimeter to dm
Decimeter
cube
is smaller than meter.
and centimeter.
so centimeter cube
10 to the power 6.
Okay.
1 dm cube is 1 liter.
Oh.
1 meter cube is 1000 liter. And you already know that 1000 centimeter cube is 1 liter. In other words, 1 dm cube.
Yeah. Got it.
Okay. So, to understand behavior of gases, let us first say that if a gas is ideal, what is an ideal gas?
an ideal gas is one that has no intermolecular forces and
A gas
negligible
is
volume of the
volume.
particles
Yeah.
itself because the distance is greater than that of the particles.
Yes. So the particles that occupy negligible distance, negligible volume, particles that themselves have negligible volume compared to the volume they occupy,
Yeah.
and the ones that have
No intermolecular
No,
force.
those are ideal gases. Yeah. If you take an ideal gas, right, and you try to keep the temperature of this gas constant, what will happen to the volume of the gas if you increase the pressure?
Increase. Decrease, sorry.
What happens to the volume of the gas when temperature decreases?
Decreases.
Right? So finally you should be able to reach a temperature for the gases such that the volume becomes zero.
Yes.
If on decreasing temperature volume decreases and our assumption is that gases do not have volume, the particles themselves do not have any considerable volume, then what should happen finally? The volume should become zero. Theoretically it becomes zero at minus 273.15 degrees Celsius, and this is known as zero.
Calibrated. Absolute zero.
Absolute zero.
So volume of a gas is zero.
Yes.
Not of the particle. Particles already zero is minus.
But then, whatever you consider, right, can it be? Because when the particles start coming near, or rather in our assumption language, if the particles are coming so much near that now they occupy considerable, they themselves have considerable volume compared to how much they occupy.
So
It
the
cannot be
volume
very
of the
complex.
molecules is negligible. Technically, the gas has zero volume,
Yes,
and that's what an ideal gas.
yes, but is it true?
No.
But it can be true for standard temperature and pressure. For a very high range, it can be true for a lot of gases. For example, it remains true for
What is
neon
standard
for a
pressure?
range of pressure, volume and temperature.
What's the standard pressure?
Standard pressure is atmospheric pressure 10 to the power 5. Room temperature is 27, standard is 25, volume is the volume at
Whatever, yeah. And temperature
will
is
depend on the number of
273.
moles.
RTB is 27.
Huh?
RTB 27.
Ha. But STP 25. At STP, the volume of gases is 22.4, not 20.
24 is at RTP. Out of the syllabus question, but how did people figure out that 0 Kelvin is minus 273.25?
Theoretically, हमने बहुत बड़ा इक्वेशन बनाया कि for this range of temperature इतना slope मिल रहा है, right? What did we do is we found out that if this is temperature and this is volume, right? And we plotted this graph, you reach this for 0 temperature or 0 degrees Celsius, right? You reach this over here. If you extend this graph, you will reach. So this was absolute. This was 0 degrees Celsius first.
Water.
है ना?
Yes.
Water.
For anything.
हाँ. 0 degrees Celsius for let's say nitrogen. तो हमको ये ग्राफ को fairly linear मिलेगा. You extend it, you find out where does it have 0 volume.
Oh.
Theoretically, the particles are zero.
This happened at. So this was 0. This happened at a value of minus 273 degrees
It's like
Celsius.
Km and K.
हाँ, yes. ठीक है, but moving on. There is one more theory. What is temperature? Temperature is the average kinetic energy of particles, right? So if you cool particles, what will happen?
Volume is energy.
Energy will decrease. Volume we have already looked at. Energy goes on decreasing. Now, tell me what will happen when you keep on decreasing the energy? There will come a point where you cannot decrease the energy anymore.
Because there is no energy.
It's not in motion anymore.
There is no energy left to decrease.
That point also theoretically with the help of graph and equations give us minus 270. So there are two ways to come to same conclusion, that there is a minimum temperature below which it is not possible to actually function.
Is 0 degree colder or minus 273?
But a minus 273 degrees Celsius.
Yeah. Is that colder or is 0 degrees Celsius?
0 degrees Celsius
Minus 273
and minus 273.5 degrees Celsius अच्छे. Both of them are degrees Celsius, bro. What we are asking is she's sleeping. Both of them are degrees Celsius. Obviously, lower one is colder.
No, because
This is
minus
0
1 is
Kelvin.
greater than minus 2. Technically, in that. So she didn't.
Exactly. Exactly with that logic, they should be colder. है ना? Yes, sir.
Which paper do I have to write some back?
What papers do you have to do?
22 to 21.
શું વાત કરે છે?
I've just done 2 hours of
Point
calculus.
four.
This is gonna fly by.
Some as with me.
भाई विराट कोहली 0 पे आउट होता है इतना दुख नहीं होता मेरे को
Oh, -1 is greater than -273.5.
Exactly.
So it's
So
a
zero
higher
is-
value of temperature. So it's higher temperature.
Yeah.
so it's hotter please है ना फंडामेंटल्स नहीं भूलवाना ओके आगे जाते हैं थोड़ा है ना ये तो हमको रिलेशनशिप मिला PV equals to nRT. Now this equation is the ideal gas equation. An ideal gas obeys this equation for fairly a large range of temperature around room temperature. ठीक है? Gases that have least intermolecular interactions will follow this equation for the longest or the greatest range. Gases like helium. It is small. It does not have a lot of electrons. It is monoatomic. So will behave like an ideal gas for a very large range. But compare the same thing with water. है ना? It is not even an ideal gas, but think of HCl. It has permanent dipole forces. It will not behave like an ideal gas for a very large range. Right? So when does the ideal gas behavior break? One, when the pressure is very high and the temperature is very low, such that the interactions become considerable. Right? The first assumption was they do not interact with each other. But somehow if they start to, that will break your whole equation. Yeah?
Wait.
So high pressure, low temperature.
Yeah. Is that an ideal gas?
Sorry.
High pressure and low temperature. Is that an ideal gas or is that like
No. The
Non-ideal
furnace
gas.
from ideal
It starts moving away from
Okay.
behavior of ideal gas. So when I write PV equals to nRT,
because the volume is so low? So
Ah.
everything is.
So ideal gas is doing high temperature, low pressure.
No.
Ah.
Yeah. Yeah.
High
high
temperature.
temperature, low pressure will be most like an ideal gas. है ना? Now there is one method of how to find out the relative molecular mass of
Yeah.
of
N
what?
की जगह.
Of your
And
gas.
And you put M upon M.
Yeah.
Right? If you remember that is okay. I am going to genuinely
No,
skip
M.
Fullerene. How do you pronounce it?
M.
I pronounce it Fullerene.
Molecular mass you want to.
Okay. However you pronounce it, and they have discussed a lot about lattice, but we have discussed about lattice whatever there was to in the last chapter. So this chapter is also, in my understanding, over.
Can you give more examples of ionic lattices? Giant ionic lattices.
All ionic lattices are giant. All of them are
There
giant.
are no simple iron.
No simple.
Same
Right?
thing with metal, no? All metal.
All metals are giant. All metals are giant. All ionic lattices are giant. Only covalent has an option to be simple molecular and a giant.
How do people know that this is giant?
By its melting and
Boiling point. It's higher than
Alright, never mind.
As if I'm not doing
Guru sir, Internet Explorer. Sir, Internet Explorer.
क्या बोल रहा है?
So she is running Internet Explorer.
इंटरनेट एक्सप्लोरर नहीं चल रहा है वो genuinely Adya genuinely she is trying the best she can actually best try कर रही है जागने का तो वो सोच रही है कि ऐसा क्यों हो रहा है मैं जाग सकूं बट उसपे वो okay hi try that keep on trying okay so we already know there are two types of reactions in terms of energy changes endothermic and exothermic reactions right what does an endothermic reaction mean endothermic reaction means that it takes in energy exothermic means gives out energy what is enthalpy enthalpy for us is the energy of change whenever a state a compound is changing in any form then we can calculate instead of finding the heat lost or gained during changing state and then breaking bond and making bond but all of that can be combined to one simple thing enthalpy now enthalpy if it is a energy of change, then let's say I can find out enthalpy of this happening. Right? 2 over here, I believe.
Yes.
I can find out enthalpy of this. How will I find out enthalpy of this? I'll take methane, I'll burn it in enough air, and I will heat water with this. Right? I will find out how much heat did water take, and I will find out how much methane did burn. Right? So heat upon the moles of methane will give me enthalpy of combustion of methane in kilojoule per mole. This is an enthalpy of combustion. There can be enthalpy of formation of compounds. Right? There will be an enthalpy of C plus 2H2 gives CH4. Right? Some processes will be exothermic. Some processes will be
Endothermic.
right. Now,
I have
Formation is usually exothermic, right?
Yeah.
what if there's only like bond enthalpy present, like only like CH and like O2.
because the name is enthalpy, it does take into consideration every small thing.
No, but like if in a it's only like CH bond enthalpy present and O2 bond enthalpy present. So we'll have to find out for each of the compounds and then subtract the products from the reactants. Right?
So don't we do reactant minus product?
Delta H is equal to delta
Product
H.
Minus reactant minus product.
No, product
Left to
minus
right, left to right. Branch करो left. क्योंकि on the left your bond breaking, on the right your bond making.
It's always reactant.
Okay, दो लोगों के question है ना? Let's look at it logically. What should be the sign of delta H when it is exothermic?
Negative.
This is exo, right? What does exothermic mean? It means that the energy released when bonds are
Made.
is greater than the energy required to break bonds. So can I say delta H of reactants is less than delta H of products?
Yes.
So what would it mean
Product
for it
minus
to be?
reactant.
Reactant minus product.
Reactant minus product, right. Sorry.
It's reactant.
Energy to
Yes.
break the bond versus energy to make the bond.
But in a graph, if it's ऊपर to नीचे, that's
So the
that's
enthalpy
exothermic.
बराबर question पूछे. The enthalpy value given to us is the amount of energy released when those bonds are made. So for this sign to be negative, there has to be more energy released when bonds are made compared to the energy required when bonds are broken. Yes.
Textbook says products minus
Yeah, so
Products
that's
minus
exactly.
So
Why this confusion exists, I have no idea. But this is true. Reactants minus products करोगे, right? तो textbook वहाँ पे कैसे आ रहा है वो भी देखते हैं. I know what is happening over there. They have made a S cycle and then they would find this out. है ना? तो वहाँ पे कुछ अलग तरीके से आएगा.
No, because the graph of exothermic is ऊपर to नीचे.
हाँ.
So to get a minus sign, we have to minus it, the reactants, the products from the reactants.
Products minus reactant.
Only then we'll get a minus sign.
But in that case, you consider energy with the products minus energy with the reactants. But when bond enthalpies are given, that enthalpy tells us energy released when bonds are made or energy required to make them.
So when it's bond enthalpy, it's
Then it
reactants minus products. But when it's
just the
Reaction.
enthalpy, right? Reaction enthalpy. So to standardize this reaction enthalpy confusion problem, है ना? Let's standardize की what are standard conditions सबसे पहले, है ना? Standard enthalpy of whatever, combustion हो सकता है, formation हो सकता है, dissolution हो सकता है, neutralization हो सकता है ना? So let us first understand standard condition क्या है. It should happen at standard temperature and pressure. Each substance involved in the reaction is in its normal physical state. मतलब water है तो liquid, sodium chloride, aqueous or solid, right? Generally for reaction we take it as aqueous, right? Also, how do you now measure? See, they have given a variety of enthalpy changes. enthalpy of formation, combustion, neutralization and अगर नहीं पता है कि क्या नेम करना है तो reaction. Okay, now देखो, for example, if I had this, I can make this as well, but this can combine to form CO2. This can also combine to form CO2 and H2O. हो सकता है ऐसा, है ना? Let's say,
Yeah.
considering that energy cannot be created, cannot be destroyed, considering कि वो true है, this is x, this is y, and this is z. Z is equal to x plus y.
Yeah.
है ना? Now you can write, अगर y नहीं पता है तो y is equal to
Z minus X. That's how I always do it.
ठीक है? ऐसे कुछ कर सकते हैं. साइकिल क्या है?
Hess
cycle. Hess cycle में सबसे इम्पोर्टेंट है जिसका फाइन करना है वो
ऊपर.
हॉरिजॉन्टल रखो. बाकी सब कुछ जहाँ जिधर रखना है. ओके, जिसका फाइन करना है उसको हॉरिजॉन्टल रखो. Let's say, huh?
Can you also tell us like enthalpy of formation is always negative? Right?
हाँ.
Yes.
Now,
Combustion is negative.
ठीक है, पहले वो कर लेते हैं. Combustion नेगेटिव हमको जो दिया है, formation नेगेटिव, combustion नेगेटिव, neutralization
Negative.
Negative.
Combustion.
Negative heat is produced. गर्म हो जाता है.
Shouldn't combustion be positive?
हाँ बेटा, exothermic delta H is negative.
But combustion means combustion requires heat.
No,
No,
combustion
that's
is
decomposition.
तो मेरी लाइफ में बहुत fire you get
Activation
heat, but
energy,
it doesn't
right? Activation energy sana. So all over it is exothermic.
Starting he repeated.
All of them are negative. We have not
Except decomposition.
हाँ मतलब
हाँ.
चार्ज डिस्कस
Yes,
करें
yes,
थे.
Decomposition.
Formation, combustion and neutralization. I am saying all of them are
negative.
exothermic in nature. ठीक है.
Yes.
क्या समझा रहा था मैं कुछ
Formation.
Negative.
Combustion.
Why is for
भूल गया मैं.
Formation
Anyway,
always exothermic. Are there exceptions in the formation?
हाँ, नहीं formation. I remember it.
I think there was some
Yes, there was one or two
exception
exceptions in formation.
कैसे?
था चलो table ही written some question that some of the values were negative, some were positive. कुछ I think कुछ organic compound का ही था. There was some CH that was positive or something that was positive.
होगा चले
देख लेंगे.
मुझे कर दो एक
अच्छा ये हेस साइकिल था. ये जो मैंने अभी ड्रॉ किया. In between all this was हेस cycle.
statement of this is no
That no matter what, like, no
what
matter
path you take
हाँ.
the energy will have.
the energy change from initial state to final state remains constant irrespective of the intermediaries or the path of the reaction.
It is like distance versus displacement.
The total enthalpy change in a chemical reaction is independent of the route by which it takes
Wow.
place.
Right? Thermal decomposition obviously positive, है ना? Neutralization में एक चीज याद रखना, जैसे let's say NaCl plus H2SO4 gives Na2SO4 and H2O.
Isn't it NaHSO4? So NaHSO4. NaCl to H2SO4 gives NaHSO4.
Yeah.
तो चलेगा. हाँ.
For example, I found out that this, if I take 1 mole of this and I take 2 mole of this, right? 2000 joules of energy is given out, right? What is standard enthalpy change of neutralization for this reaction?
When 1 mole of water is produced, नहीं 1000 moles.
1000 mole
1000 joules, sorry, 1000 joules.
per
Mole.
right? Why? Because 2 moles of water is produced. How much ever energy is produced, divide by the number of moles of water. Because what is neutralization? Neutralization is H plus plus
Oh,
H
when
minus.
1 mole of water is formed from acid base under standard temperature pressure.
Right? That is standard enthalpy change.
हाँ.
Here 2 moles of water is forming. Therefore, you divide that energy by 2.
Okay.
ठीक है, ये भूल जाते हैं सब लोग। एक बहुत ही
How do you know
भूल ही गए थे
when you
question,
have
हाँ,
to like
check point.
equate the whole thing like in a linear
हाँ, तो I
equation?
am saying how about you bring me a board का question, right, जिसमें they have asked some complicated enthalpy changes. I believe enthalpy changes में तुम्हारे पास question होना चाहिए, तो लाओ।
And when do you know you have to add a compound?
એના માટે question આપણે કરીએ બેટા.
Sir, paper now. I have 20
But I
minutes.
MC
Sir, 2 सेकंड पेपर. Sir, अच्छा इसके पास है. Sir, all the Riverside people have combined.
Friendship टूटी रही.
What paper?
Okay, this is 210 and 23. हाँ, it is question number, no idea. Question number 1, part E. Okay. So they have given POCl3. This is the type of question I was asking. कि POCl3 forms from PCl3 when it reacts with O2. Table 1.3 gives some relevant data. Okay, enthalpy change of formation of PCl3 is given. Enthalpy change of formation of POCl3 is given. O2 to 2O gas, that bond enthalpy is given. Right? They have asked to define enthalpy change of formation, that you've done. Calculate the bond energy of P double bond O using the table 1.3. So this is the reaction. PCl3 plus O2 gives POCl3. Okay. Now they are saying that the formation of PCl3, right? Let's form this PCl3 P plus 3Cl2. So I would write a 2 here, है ना? Plus O2 and 2P. So it can give this also. These elements can react to form this, and this can react to form this, and these elements can directly form this. Right? So your first step should be finding out the enthalpy change of this reaction. So here they have said that formation of POCl3 is minus 592 multiplied by 2 because there is a 2U over here. है ना? This is 289. Multiply this also by 2. Right? Let's say this is A, B and C. Can you find out B is equal to C minus A? Can you find out the value of B for me?
So but won't we have to take into consideration the oxygen as well, because in the question, like in the table,
First we will find out what is the enthalpy change of this reaction. Then we will consider breaking and making of bonds. It is true we should, that will give us a faster answer, but to break it down into smaller parts, we can do this.
Negative 606. Negative 606.
So B is equal to negative 606 kilo.
किसी वहाँ से प्रोटेक्टर है? ज़्यादा मान लिया बट
Papu.
चाहिए सर आपका मुझे
Okay, once you know this, right? Can you also say that how does this PCl3 plus O2 becomes POCl3? कैसे होता होगा? Phosphorus can form 5 bonds. है ना? Here this is something like this Cl, Cl and Cl. This O double bond O breaks. है ना? And phosphorus forms 2 new bonds with oxygen.
Oh.
So you don't have to do PCl bond and
I don't require PCl bond का bond enthalpy here.
So why did you do that?
I did not find the PCl. मैं तो equation
just
ही
found
find
the
करी.
change in energy the whole equation.
I found out the reaction enthalpy. That is required. I did not find the PCl enthalpy. A reaction enthalpy जो है, this whole thing. Makes sense? Makes sense.
So you minus that with this.
Now,
So minus
let's say that how much is this? This is 496, right? Okay?
Yeah.
Making bond releases energy.
Yes.
So 606, right?
P double bond O.
This requires 490. For this to happen, it requires 496 joules of energy, right? And some of the energy is released when P double bond O is made. There are two bonds made. And this results in so much energy that the process is exothermic. It has 606 joules of energy given.
so minus
Even
2
when 496 is required, ये इतना एक्सोथर्मिक है कि फाइनली प्रोसेस इज 606 किलो जूल लिख दिया भाई, तो ये भी किलो जूल होगा आई बिलीव.
The whole thing will be.
So P double bond O
551
is equal to
minus 606 minus 496.
minus
That's 551.
and then
That
divide
is
by
minus 1102. Divided by 2. So minus 1102 upon minus 2.
Divided by 2.
Divided by minus.
So divided by minus 2.
हाँ तो minus minus कट हो जाएगा ना.
Which is
हाँ,
551.
minus minus कट हो जाएगा.
Yeah. Yo.
ठीक है. Obviously you could have taken this equation and added it over here instead of B. एक स्टेप कम हो जाएगा.
No sir. Long लंबा देखो पर.
But I believe कि if there is clarity कि क्या कर रहे हैं तो एक स्टेप ज्यादा होगा तो फुल मार्क्स मिलने के चांसेस डबल होते हैं.
Sir, we have this entire paper as a doubt sir.
पूरा पेपर नहीं अभी भी
Chapter बना होता है.
इसके पीछे का
Chapter.
इसके पीछे भी.
Chapter.
एक करी ना तू रुक जा.
Curve paper था. इसके पीछे भी है फुल.
बेटा ये अच्छा ओके.
Chapter बच्चे को doubts पूछी शेयर किया.
हाँ
हाँ खाली enthalpy में नहीं है.
ना एंथैल्पी ना.
Bonding को ढूंढ.
इसकी पूरी एमएस देखनी पड़ेगी.
अच्छा हाँ obviously enthalpy states of matter and bonding but nothing except that. मैं ये कर रहा हूँ अभी ये वाला rate of reaction क्या है तो वो next time जब करेंगे तब फिर से पूछ लेंगे.
उसके नीचे वाला.
हाँ ये कर देते हैं. हाँ वो कर लेते हैं. Reaction may occur at faster activation energy again rate of reaction वाला तो वो तब करेंगे. पहले समझा दूँ वो टॉपिक. Yes. हाँ लखू ये 22MJ20 seems like this is question number 3 part BII. ठीक है. 1 gram of sucrose is completely combusted. The heat energy produced is used to increase the temperature of. Okay, so I will use H is equal to MC delta T. Right? What is the mass of water? The mass of water is 50 gram. What is the specific heat capacity of water?
4.2.
That is not given here. It is generally given in data booklet. Now that you don't have data booklet, it will be given here. ठीक है? 4.2 multiplied by
15.7.
delta T, which is 15.7. It is nothing but 40.7 minus 25. Okay? What will your answer be?
Divide by 1000.
Answer.
X kg.
into 4.2 into 16,485.
But because this energy is generally measured in kilojoules, 16.485 kilojoules. ठीक है? Now they have said that आने मोल्स में नहीं करवाना बेटा. 1 gram of sucrose की पूछे. Na मोल्स में करवाना है, sucrose ने मोल्स में करवाना. Water में मोल्स में थोड़ी करवाना.
But divide by moles नहीं करवाना क्या?
No moles, sucrose में मोल्स एक तो फाइंड करो.
अच्छा करवाना चाहिए ना जैसे
ना so this is not the answer.
How?
1 gram of C12H22O11. What will be the mass of this? 12 into 6 plus 22 plus 11 into 16. It is 342. Right? Now, 1 gram. What is the number of moles? 1 upon 342. Right? 16.485 divided by 1 upon 342 will give you
The answer.
kilojoule per mole में
5637.87 in kilos.
So
okay
23 mj.
भाई 2-3 MJ 2-3 का क्यों पूछ रहा, पेपर कराना बाकी है यार। अच्छा तुम लोगों को होमवर्क ही दे दिया मैंने सबको। 2-3 MJ 2-3 question 3 part 3 II. Okay, calculate theoretical maximum temperature of mixture in this experiment. Assume that enthalpy change of neutralization of NaOH and by Ashwin, ऐसा तो मत करेगा कि तेरे को करना बोरिंग लग रहा है तो तू मेरे को पकड़ रहा है कि करो।
सर आपने सर पूर्ण पेपर में आया।
सर ये कैलकुलेशन में डाउट नहीं था, कैलकुलेशन में लोग का डाउट था, मुझे पूरे क्वेश्चन में डाउट था। As in,
Oh, this is something
I did not like the question.
I did not like the question.
So the
I did not like the paper. Go for it to the paper. You
This is
have
the
to
equation.
This we got.
They are saying that the enthalpy change of neutralization is minus 57.1 kilojoule per mole. So how much enthalpy should be given here if 1 mole of that was used? Is 1 mole used or not? Let's find out.
We can have to calculate something.
Can you do the whole question?
अरे ऊपर enthalpy change of neutralization.
ना ना any नीचे वाला जो
Use experiment 1 to calculate the amount in mole of H2SO4 that is neutralized in the experiment. So you have taken 50 centimeter cube of 2 mole per dm cube NaOH and you have taken 60 centimeter cube of 1 mole per dm cube of H2SO4 which is in excess.
Anyway, नहीं H2SO4 2 1 100 upon 2 is 50, that is 60. So H2SO4 is next.
H2SO4. How much of the H2SO4 will be used?
50.
50 centimeter cube will be used. है ना? और can I say 50 upon 1000 मतलब कितना हो गया? 0.05 moles of H2SO4 is used. Therefore 0.10 mole of H2O is formed. What is the enthalpy here or how much is the heat energy given out? Huh?
So it was a 20.
So
Our question was they've given us a lot of data in nature. E is equal to mc by t and then find the final temperature or something.
अरे हाँ पर मैंने पहला H E ની value तो જોઈ સર mc delta t करा માટે
Each है 57.
हाँ अरे this answer is 57. What is this answer?
Negative 5710.
Oh भाई रुको shit.
This is the amount of energy given out when this neutralization takes place. So minus 5710 is equal to mc delta t. What is m? So you have taken 50 centimeter cube of this and 60 centimeter cube of this. So the mass of water is 110 gram. The value of C is 4.2. Let's say delta T is not known. Can you find out the value of delta T?
Yes.
Once you know the value of delta T and you start at room temperature, can you find out?
12.359. Negative 12.359.
See, you,
That is
this
delta T.
negative sign exists to show you that the energy is given out.
So positive 12.359.
MC delta theta का mass calculate the mass used or all the mass?
Total mass of
The
water.
mass is
Total,
conserved.
yes, total mass of the mixture.
So temperature क्या जैसे मेरे
Room
initial
temperature कितना?
Initial, अरे delta T कितना होगा?
12.35.
12.35. देख क्वेश्चन में लिखा है both solutions have a temperature of 21.4. So 21.4 plus 12.3
33.7.
degree Celsius.
अबे यार मैंने कुछ गड़बड़ कर दिया।
110 कैसे आया?
50%.
भाई ऐसा मैं बोल रहा हूँ तो सुनो. 50 and
That's
60
the combined
centimeter cube
mass.
of water. The question tells that 1 centimeter cube of water is 1 gram of water. So the total water is 110. Even if the H2SO4 is not used or sodium hydroxide is in excess, whatever, but that amount of water is there, the temperature will increase for the whole water, and therefore you have to take M as 110.
So the amount of H2SO4 neutralized.
0.05
How
mole.
about question?
You find out which is in excess.
Okay.
અને પછી એના પ્રમાણે.
6 and 9.
Okay, this is 1, 2, NJ23. Question number 6. Which statement about Cl and double bond O? Okay. Which statement about this molecule is correct? Each molecule contains 1 sigma and 2 pi bonds. It contains 2 sigma and 1 pi bond, right? The second bond is pi bond. The first bond is always sigma. It is a non-polar molecule. How would you know it's a non-polar
It's
molecule?
not illegal. I don't understand why it's legal.
It is a linear molecule.
No.
Will it be a linear molecule? No. This has one lone pair, right? Then nitrogen atom is sp2 hybridized. Acha. Okay.
One question.
If there is only double bond, it is sp3 hybridized. For carbon and nitrogen both, if they are double bond, then sp2 hybridized. For triple bond, they are sp hybridized.
So nitrogen has 3 bonds.
Beta, there is a double bond.
हाँ.
If there is a double bond, the hybridization must go to sp2 to achieve a side overlap.
So you don't count the total number of bonds. You only count the highest number. Any partial assignment.
And then in the same paper, question number
9.
કેમ આવું પૂછે?
કેમ કે જે ફાઇનલ આન્સર છે ને એ લોકોનું it's just mc delta theta. But when you do mc delta theta divided by number of moles, you are getting C. But એમનું જે આન્સર છે it's just mc delta theta, but it's still in kilojoules per mole.
Okay. This is जिसको भी देखना हो 12 MJ23.
ना.
Question number.
મન નહોતું આવતું.
પણ તે
Number of moles is 0.1 and not 0.2.
Why not 0.2? Total number of moles is mixed.
Okay. Question number 9, 1 to MJ23. Question says you have 25 centimeter cube of 4 mole per dm cube and 25 centimeter cube 4 mole per dm cube of sulfuric acid, no, hydrochloric acid and sodium hydroxide. So you have HCl and NaOH. The neutralization is H2O plus NaCl. Right? So you find out moles of 1 because they will react in equal moles. You find out mole of 1, the whole thing follows. Right? So you have 25 centimeter cube of 4 mole per dm cube. So you have 0.1 mole of water forming. Right? If that is clear, they have said that the initial temperature of both the solution was 15. Right? Can I safely say that M is going to be equal to 15 gram?
Yeah.
Of both છે ને.
Total, right? C is 4.12,
4.18.
18. And delta T, what is delta T in the question?
Delta T is 15.
15. The temperature, the initial temperature of both solution is 15. Maximum temperature recorded was 30. So delta T is 15. H is equal to MC delta T. So 50 into 4.18 into 15 divided by 0.1 will give you answer in kilojoule per mole. What is happening?
Why not 0.2? Because if we're taking total mass, shouldn't we be taking total number of moles?
Beta, we should be taking total number of moles of water formed.
Because it's enthalpy neutralization.
Neutralization.
Okay, क्योंकि 1:1 ratio से खाली 0.1 बीजू कोई ना मोल आपने consider नहीं करा.
Heat is absorbed by all the water present.
Correct.
But what releases this heat? 1 mole of water.
But પછી એવું ના થાય કે if we're only considering moles of water, we should only be considering mass of water because the 50 grams is mass of everything present, right? Technically. જે આપણે 50 લીધું છે, it's mass of everything in the reaction mix, question, correct?
But
If
what
you-
is it making?
H2O and NaCl. NaCl.
Solution of
हाँ.
NaCl and H2O.
But
Solution में હોય શું? Water.
and NaCl.
But NaCl is so less.
That it is.
It won't affect the.
है ना?
How do we know that?
Would you not assume NaCl has mass?
Okay, go home
हाँ.
and take a pinch of salt and find out if the mass of a glass of water changes enough that you can measure that change. Does not.
हाँ.
There is already energy released when dissolution takes place.
But it's.
I get what you're saying, but also I would think in terms of 0.2 in an exam. If I
And it's enthalpy change of neutralization. So
How?
neutralization of hydrochloric acid. Should we be taking hydrochloric acid?
No.
Money always.
Moles of water form.
Okay.
Samya Pascal.
Yes.
So,
Yes.
so in a question like this, for example, there are 10 electrons in the outer shell of phosphorus, but why? Like, I get that like, it happens, but Q.
Explain it out.
Yeah.
But Q.
Muscle?
But like,
उसको
RT of होना, and how do you know when it's an extended octet then? Like, there was one more question with S math, like, which was an extended octet in sulfur or something. How do you know when it's an extended octet?
SF6 में क्या होता है?
But like,
It has 12 electrons in its outermost shell.
but wait, but Q.
In a way वो d orbital empty है वहाँ पे accommodate कर रहा है. What is the next?
I have
3D.
a doubt.
4s के बाद 3D आएगा.
बस
Easy answer.
A पति का बटला है.
हमने बोला
I
है.
have a doubt
बुक में बोला है.
the last.
हाँ पूछिए. सारे पूछो.
No. मारो जाता है. जब पूछो.
थोड़ा सारा पूछो. Please.
सारा जाता है.
In mass spectrum of D, relative abundance of molecular ion D is 3.4. Predict the relative abundance of M to P for D. Explain your answer. You go to D, you find out that it is Br. The possibility of Br being 79 is equal to the possibility of being Br 81. So if here the abundance of one P is 3.4, the abundance of other has also to be
3.4. And that's the answer.
So, I have a doubt in the mole question. It's not the PV and RT, it's just moles.
रश्मि अरे तो कैलकुलेटर के साथ कैसे खेल रहा है
बोर हो रहा है.
तो घर चले जाइए you don't have doubts you don't want to sit you can go like genuinely
But then, what if others doubt?
Yes.
compound X an anhydrous group 2 bromide is dissolved in water titrated against silver aqueous silver nitrate solution contains X okay identify X okay
Paper.
So कौन सा पेपर है? Have you done this? Oh, yes.
Question number 2 last question
Oh.
okay compound X an anhydrous group 2 bromide okay is dissolved in water and titrated against aqueous silver nitrate so AgNO3 plus MBr it should be MBr because it is group 2
It's MBR2.
उधर
group 2 bromide
हाँ,
or it is
MBR2.
Br2 it is Br2 right this reacts they are saying that
Sir, are you sure 2 plus 2 3?
Yeah.
Yes.
Yeah.
Question
ये वाला.
B.
अच्छा question 2 last.
Two का last.
इसको लगा second last. तो पीछे से देख लीजिए.
It's okay.
No problem.
ठीक है हाँ हाँ कोई वापस ओ इधर देखना भाई
हाँ sir.
a solution containing 250 grams of X requires 33.65 centimeter cube of 0.05 mole per dm cube of AgNO3 for a complete reaction. So this should form AgBr. 2 AgBr. So 2 over here. है ना? If this all is clear, can you find out the number of moles? So 33.65 upon 1000 multiplied by 0.0.
1.678 into 10 raised to minus 3.
This is the number of moles of AgNO3, है ना? This means that how much is this? उसका half, which is
8.4125.
8.39 into 10 raised to minus
39?
4.
अच्छा राउंड करते हैं
10 to the power
Minus 4.
minus 4. Right? Now, can you say that 8.39 250 gram of X? So 8.39 into 10 to the power minus 4 is equal to 250 gram. So 1 mole is how much? ऐसा कुछ find कर सकते
Yes,
हो?
yes.
That's not really necessary.
Right? I mean, if it is not necessary, what else
No,
do you do?
So this is how we'll get the MR.
We'll get the MR,
And yeah, okay.
You
I
subtract
didn't
the-
write that step. This is very nice.
है ना? तो you subtract 79. Okay, you look at your periodic table, you will find that 79 है शायद. 79.9 I think is the answer. So you subtract 79.9 into 2 from whatever answer you get over here.
BA.
Right? And then whatever mass you find out in group 2, who has that much mass.
Barium.
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 Bro?
Behavior. Bubble. Bubble.
हैं?
कौन सा?
I have a question in this.
Oh, very crazy हो गया.
So
और राइट से पहला तो मार्क्स निकल देना होगा सब weeks.
3 enough.
3 na 4 na. So 2 FM 23 question number 3 part A part 4. Complete reaction 1:1 mixture produces only the product mixture contains 96% A and 4% B. Calculate mass of A produced in this reaction. Okay, complete reaction of protein. Grow with a mixture of CO and H2 produces A and B only. Okay. The product mixture contains 96% A and only 4% B. Calculate the mass of A produced in this reaction when 5 into 10 to the power 3 kg of propene is used. MR of propene is 42,
Yes.
right? So how many moles of propene are you taking?
सर पेपर कौन सा है? Sorry.
Paper है
Same है.
22FM23.
अच्छा वही last question.
Question 3A4. Okay, 42 इसका मास है. फिर divide, so basically 5.00 into 10 to the power 3 into 10 to the power 3 because it is kilogram, divide by 42 will give you the moles of C3H6, है ना? दीदी A and B is given ऊपर है ना, masses છે આપણી પાસે જો blindly A and B નથી find કરવાનું.
सर तो ना just
એટલે આ ક્વેશ્ચન આટલો લોસ લાગે છે તને, સમજે?
Oh.
Sir, તમે અમને નોટ્સની QR કોડ આપી શકો છો? તમે સ્કેન કરી શકો.
અરે આનો વિડિયો બને છે, ઘરે બેસીને પોઝ કરી જોઈજો.
આમ વધારે easy છે notes. So like all the notes that you gave.
I think as soon as I shut this off तो बंद થઈ જશે QR की, but sure લઈ શકે છે QR.
Our realized almost in every year 2-1 and 2-3 is same.
हाँ, it should be.
अच्छा it is
Very
same.
well, चाल से वीडियो पॉज करी.
Why is it same?